Welcome viewer and welcome to Artistry. My name is Daniel Ndungu from SOS Technical Training Institute, Nairobi. Today's topic will be on safety. We have been discussing about the fundamentals of electricity, and we have discovered that electricity is a form of energy, and there is a risk that is always associated with all forms of energy, in that if they are not used in the proper way, they can cause destruction. And this destruction in electrical can be in form of fire or electric shock. Because of the risks that are involved, it is always very important that those who are using any form of energy must have a basic concept on safety. Though when we talk about safety, we are talking about measures that will be taken to reduce or minimize the risk of accidents happening. We all know that it is hard to eliminate all the factors that could cause an accident, but we can, by much success, reduce the risk of reduce the chance of an accident happening. And that one is very much emphasized in electrical installation, simply because other than fire, electrical installation can lead to electric shock, and in case of an electric shock, the electric shock can affect both human and animals. It can affect both humans and animals. So the risk is there. When you compare electricity with other forms of energy, like maybe petroleum and the like, you find that the physical contact with the product might not be dangerous, but with electricity, we would want to avoid, or we greatly avoid any physical contact between electricity and humans and animals because of the risk that is there. So that's why a lot of care must be taken. When it comes to fire, what happens is that fire here is also another risk area, because in electrical, fire might not necessarily be ignited, but fire can result from the circuit itself. This is because when electricity or when the current is flowing, we have electrons flowing. So if we have a very large amount of electrons flowing, then there is the possibility of very high collision, and a lot of heat can be generated, and this heat generated can cause ignition, or it can ignite materials that could be near, and thus we create, or there is a creation of fire which can be very destructive. When you look at other forms of energy like petrol, for petrol to ignite, you need to light fire. But for in an electrical circuit, for fire to be there, you don't need to light any fire. There only needs to have a very high amount of electron fluid, and these electrons generate heat. And the funny thing is that the heat here generated, it is generated within a very short time, a fraction of a second, and then the result would be ignition, and fire would result to that scenario. So there are steps that can be taken to avoid these risks. There are steps that can be done to reduce these risks, and the first one is to make sure that when we are handling electricity, we use protection we protect the circuit, and we protect the circuit such that we don't have a very huge amount of current flowing at any particular moment. And this protection is offered by a fuse or circuit breaker. We use a fuse or a circuit breaker. This, of course, reduces the chance of us having a very high current, reduces the chance of high current flowing. That is number one. So in all the circuits that we are connecting electricity, they should always be protected by a fuse or a circuit breaker, so that we reduce the chance of a very high current flowing, and which would result to heat being generated and fire being the end result. So that is one. The other thing that we need to take care is to make sure that we do not come into contact with electricity. We don't come into contact with electricity. And this is done very well, because when you look at all the electrical appliances, they have a sheath, and it is not possible, or it is very hard, or unless you intentionally try to meddle with how the equipment is operated, you cannot come into contact with the conductors that are carrying current. Now, other than that, other than the risk of electric fire, there is the risk of electric shock. What is electric shock? Is the current that is flowing through your body. And our body, the way our body operates is that we have nervous system, and our nervous system operate in form of an electric pulses that are sent from all the points of our body to the brain, and that enables us to have a sense of so many things. Now, if we have electricity, or if we have this current flowing in our body, then it results into unusual behavior, because the current that flows in our body to operate our nervous system is quite low. So if we go beyond a certain threshold, you find that the body will not function properly. And for an electric shock to happen, the threshold of pain in electric current is 3 milliamperes. That is 1 ampere divided by 1000. So what you understand is this is a very small current. This is a current that cannot be able to operate most of the equipment that we have. But if you allow a current of about 3 milliamperes to flow through your body, you start feeling pain. So when you have this, you get pain. Anything less of this threshold, you might not even feel it. Because the current is too small, and you will not get anything. But if the current is above this, then you'll feel some pain. Now, what causes this current? This current comes or is caused when you touch a live part. When you touch a live part. A live part means that between that part and the general mass of the earth, there is a potential and there is, of course, some voltage. There is voltage. So a live part simply means that between that point and the general mass of the earth, there is a voltage. So if a human being comes into contact with such a part, then it means that he'll be also a closer voltage, because there is a potential between that part. Our body have some resistance. They have some resistance. Our bodies have some resistance, and our body resistance is quite high, because when you are on a dry surface and everything is dry, your body resistance will go up to 100,000 ohms. 100,000 ohms. But if you are on a wet surface, this body resistance is likely to decrease, and if it decreases, now according to Ohm's law, which says that I is equal to V over R. Remember, your body resistance forms R, and voltage is dependent on the voltage on the live part. If you are in a domestic setup, our supply voltage is normally 240 volts. If you are between live and neutral, you will of course be exposed to that voltage. So what happens is that when you touch a live part, a current is of course going to flow through your body, and when this current flows through your body, what will happen is that if this current exceeds this threshold, you are going to feel something. If your body has, if for one reason or another, your body resistance is not as high as this, then, and it is lower than this, then it means that the risk of a higher current flowing through your body does increase. And this is, of course, can be very dangerous. And this one do happen to both human and animals. For animals, it is very, very dangerous, because bodies of animals have much lower resistance. They have much lower resistance, and as such, if they are exposed to a voltage that is as big as 240, then the result is there will be a fatality, because the current will of course exceed this, and it will be destructive to the parts. So what happens is that when you have this current flowing through your body, what happens is that this current causes your muscle to contract in a manner that you cannot control it. And what the end result is that you cannot control the movement of your arms, neither can you control the movement of your legs, because the way they are contracting, your nervous system cannot be able to control that. And that's the reason why you find that if someone gets an electric shock, of course, they have to be assisted by either isolating the live part or by removing them from the live part, because they are no longer in possession to control their muscles, and that one is very, very dangerous. Now, if you get an electric shock that where you have a higher current flowing through your body, what happens is that this current, if the current exceeds this, if the current exceeds that, what happens is that the heart muscle will, the rhythm of the contraction of the heart muscle is destroyed, and most likely if it is destroyed, they resort to fatality. So what happens is that if somebody gets an electric shock, and whereby a current of more than 30 milliamperes passes through their body, what will happen is that they lose the heartbeat, and that in most cases will be fatal, because they must get assistance to get their heartbeat rhythm restored, or if it is not done in a very short time, then the person might not be able to survive. Other than the contraction of the muscle and the heartbeat rhythm being destroyed, when you have higher current like this flowing through your body, they resort to electrical burns, whereby your body tissues are burned because of the amount of current that is flowing, and the burn is of course very, very deep, because it is not on the surface, but the burn is all over where this higher current is flowing, and that can also be very, very dangerous. So we advise population, or we advise people, that if they get someone who is getting, or who is in an electric shock, the first thing that they should do is to isolate the source of supply. If they cannot be able to do that, and you can only be able to isolate the source by switching off the supply. Switching off the supply, what you are supposed to do is that you are supposed to rescue this person by using an insulated material. And the first caution is that you yourself, the person who is performing this act of trying to rescue somebody, must of course themselves be very safe. Do not risk your life, because instead of having 2 fatalities, we better only have 1. So the first thing you should know is that whether yourself you are safe. Then if you are safe, then try to rescue. And there are only 2 ways. Either you switch off the supply, or use an insulated material to try and remove the person in contact with a live part. And once that one is done, what you should do is you should check whether the person is able to breathe. Because most of the time, when someone gets an electric shock, what happens is that because of that contraction of the muscles without control, that might affect it might affect their lungs, and as such, they might not be able to breathe. So the first thing you should check is whether they are breathing. If they are not breathing, you should be able to administer first aid, either mouth to mouth or another resuscitation method, so that you get the victim into breathing again. Because again, if they are not able to breathe, then there is a risk that you might lose them. So the first thing that you should check is whether they are breathing. And don't assume, because they are not breathing, they are dead. Don't assume that they are dead, because most of the cases, you might have someone who is unable to breathe, but they are still alive, because either the lungs have been affected by one way or another. So check for signs of breathing. If they are not able to breathe, help them to breathe. If they are breathing, what you should check is whether they are in a safe place. If they are in a safe place, the other thing that you should do is call for emergency help, so that these victims get they get medical attention, so that they can be safe again. In conclusion, we say that electricity is a good source of energy, but this source of energy has risks, and we have seen that we have 2 main risks That is the risk of fire and the risk of electric shock. And we have seen that what entails in electric shock, and first aid is very, very important so that you save the victim. And by that, we come to the end of our lesson today. Your presenter was Daniel Ndungu, and stay tuned.